All right, good afternoon, everyone. Thank you, and welcome to our session, SEC Security 319. We're going to be talking about how you can meet enterprise security requirements with AWS native security services. My name is Saurabh Saxena. I'm one of the TAMs on AWS Enterprise Support Organization. As part of my job, I work day in, day out with customers like yourselves and help them with their cloud journey. I've been working with General Electric, GE, for over 5 years now, and I do have Thomas Wold and David Strum from GE who will be joining me in this session to deliver a talk. This is a 300-level talk, so we won't be talking a lot about the services and how they operate, but we will talk a lot about how General Electric uses those services, and so can you as customer to achieve these outcomes that you probably have today or you have requirements from your CISO or security organizations. Quick agenda. We'll talk about some of the challenges and objectives as you face every day related to security. We'll spend a little bit of time talking about security off the cloud and security in the cloud, specifically around AWS shared responsibility model. Then we'll give you a little bit of overview of AWS security services. You're not going to find some of the services that we just announced this week, but we will talk about a lot of those that are already out there, and you can use them, pretty mature services. Then Thomas from GE will talk about automating asset identification in the cloud using AWS native services and how you can implement proactive protection. And then we'll have David Strum come in and talk about operationalizing threat detection into day-to-day processes, as well as how do you automate incident response. Some of the key takeaways we want you to take away from this session is how you can get more visibility into your AWS environment and make your workloads more secure as you distribute them out to your businesses, and make it more secure for your consumers to access those workloads. And then towards the end, we'll talk about using AWS services like SSM, Lambda, step functions, how you can automate threat detection and incident response. This slide should not be a surprise to most of you in the room. If it is, please do find us after this session. We'll be happy to talk to you about it. This is a very common AWS shared responsibility model. As you start deploying your applications in the cloud, get on your cloud journey, there's difference between what AWS controls, governs, and also what AWS has visibility into, and then what responsibility lies on the customer in the shared responsibility model. If you look at this picture, you can see we take very good care of the cloud. We have our compliance reports, SOC reports to provide to you that you can give it to your auditors if they do talk about it and if they want it. But then once you get in the cloud, we provide customers ability to, and it's their function to deploy security in the cloud. But it's not just about we letting you decide what you want to do. We provide you mechanisms and tools that you can use on a day-to-day basis to implement your security in the cloud. Some of the aspects of security in the cloud includes your data, your platform applications, your identity, access, authorization, who can do what they can do, are they even authorized to log in? Okay, once they log in, are they authorized to make a certain action? All of that is the responsibility of a customer, but we provide tools and services for you to provide central governance to do that. And then operating systems, patching, network security, firewall, VPC security groups, and NACL, we do provide you tools to do that as well, but that's the responsibility of a customer. A quick recap of what security solutions we do provide. We do provide you identity-based solutions. You have AWS organizations that allows you to create policies and implement that at a group of account level. You have identity and access management. You can create users, keys, roles, and then you can also allow external authorizers to assume a role in your account and take certain actions, and you can specifically limit what they can do. Then you have Cognito that can provide you user base for your mobile apps as well as SSO capabilities. AWS directory services, you can start from a simple AD, go all the way to Microsoft AD, and then you can tie it back to your on-premises AD as well. And then you have our service called AWS Single Sign-On. Then we also provide you services around detective control, so CloudTrail, Config, CloudWatch, infrastructure security, EC2 SSM, Shield, WAF, and we'll talk about all of that in coming slides, as well as how GE uses these services to achieve the outcome and meet their security requirements. Data protection, we have KMS to encrypt your data, Cloud HSM if you want to manage your own HSM or bring your own keys, Macy, certificate manager, server-side encryption. Similarly, on incident response, you have Lambda, config rule, CloudWatch events. The list just goes on. This is a common alignment with AWS services. It's a pretty common framework. You might have seen it in the past. You want to identify what needs to be protected, then go to protect. How do you proactively protect it from threats? If a threat does happen, how do you detect it? And then how do you respond it? But you don't want to do any of it manually. You want to create and deploy controls that can do this for you. And that's what GE is going to talk about, identify and protect and how they do detection and then automated response. And then the recovery piece is handed over to the business on what they think is best for, on how do you want to recover their application that has had a threat. In our identify portfolio, you have services like CloudWatch that looks at your metrics, and you can set up alarms based on that. You have EC2 Systems Manager for knowing the patch status of your environment in a centralized location. You have CloudTrail that records and manages every API that's out there. AWS Config that's looking at the change of your state of your resources and can trigger specific actions if it changes. You have GuardDuty that's centrally looking at all of your logs and finding anomalous behaviors and alerting you on that. You have Inspector for vulnerability assessment, Shield, Macy, VPC flow logs. Again, all of these services together allow you ability to identify what's happening, what needs to be taken action on, and on a centralized basis and on a regular basis. When it comes to protection, how can you protect your environment? Now that you have identified what needs protection, you have IAM for user, key, session, role management, EC2 SSM, Shield. You have AWS Web Application Firewall, where you can set up rules for certain set of IPs that you want your web applications to only receive traffic from. You have CloudFront, tied in with WAF, Certificate Manager, EC2, VPC, security groups, NACL, to provide a host-level protection or VPC perimeter boundary level protection. And then now you have identified assets, protected it. How do you detect them? What are the services that's available? In this portfolio, we have CloudTrail that records and manages all the APIs. You have Inspector that can tell if there's a vulnerability assessment or your instances with Inspector agent have any specific kind of vulnerability. You have GuardDuty, flow logs, Amazon Macy, constantly looking at your S3 buckets and finding who is accessing, what is being accessed, and if there's any anomalous pattern that you want to take action on. Let's say now you have done identification, protection, detection. Now you want to respond. Some of these services, config rules, CloudWatch events, Lambda. You can trigger actions based on what you find in these data sets, and then those actions could be automated so that next time if the same thing happens, the action would be taken, the resource would be isolated, and then you can do forensics on that. So in the response section, you have step functions, Lambda, CloudWatch events, EC2 SSM has a whole portfolio of things that you can do to respond, like parameters show, maintenance windows. You want to patch on a specific schedule your Windows or Linux instances, you can do that. And then once you respond, you want to recover, right? What are the things that you want to deploy? And that's where, again, you have Lambda, step function, Amazon SNS, where you can trigger notifications depending on who specifically owns that resource, and they should be notified, and they can take action on that. SNS supports email, or you can push to HTTP message, or you can do iOS push, Android push, things like that. Then we recently announced today, actually, in Werner's keynote about Lambda and how you can now bring actually a custom runtime. So in the past, if you had limitation that you want to automate respond, but your application behavior doesn't support the code functionality, you can now bring it over to Lambda and do that as well. So coming back to this slide, where again, how all of this ties together, you start from identifying your asset, what process and assets and resources needs to be protected, and then you implement controls centrally and govern them so that they are protected at all times. Just in case if there is a threat that happened due to any reason, you want to detect it as soon as possible, and then you detect it, and then you want to respond to it in an automated way. You don't want humans to be interacting with, somebody gets paged, they log in, and they log into the box and try to do something. You want it all automated so that as soon as a threat comes out, you're able to respond to it. And then towards the end, how do you want to recover? So we talked about identification, protection, detection, and then how you can automate respond. I'm going to invite Thomas Wold from GE now, and he's going to talk about identification and protection, how GE does it at an enterprise massive scale. Thomas.
Hey, so My name's Thomas Wold. I've been at GE for about 3 years now, and I'm on the external hosting team. And basically, our team is responsible for the design and implementation of what I think is now commonly referred to as guardrails. For those of you who have seen the landing zone product that comes out, we've built out an environment. We worked with AWS and kind of gave them feedback on that product. And we basically have something very similar, right? So when we built ours, though, we really had the goal of merging enterprise controls and requirements with an AWS experience that all of our application teams and all of you guys as developers are really familiar with, right? We didn't want to turn something in that, if it's opening an account or launching a host or something that's more or less on demand, we wanted to be able to secure that, but not really add a ton of time to the delivery of the product or the service. So in order to do that, we really had to define a few things, right? We had to define what our experience was like, really understand our enterprise. And so if you look at GE today, our challenge is pretty vast. We're in 180 different countries. We have over 4,000 locations, and a company that's been around for 125 years, so there's a lot of old processes, there's a lot of new processes, and then there's a lot of different systems and components that all need to be integrated. And where we're at today is that we have about 500 different AWS accounts. We use almost every service in the catalog, and to date, we've migrated about or deployed 3,000 applications in AWS. Really, the biggest challenge there is because we're so vast, because we operate in so many different verticals in so many different countries, we're literally subject to just about every regulatory body you can probably think of, depending on the team, the vertical, the industry, et cetera. So that really kind of drove us to a set of requirements. As we talked about, we have a shared responsibility that crosses many, many teams. We wanted to have really tight SLAs that are kind of in line with Amazon, or when we're extending an SLA, we wanted to make sure that we provide value add that was commensurate with the time and the additional overhead that we're adding. So we really came to the point where we said, hey, this needs to be self-service, and tickets are basically a defect in our process. We just can't build out a team big enough to service that size of an organization. Again, we talked a little bit about the compliance requirements, and we wanted to make sure that we met everything that we could that's very general and applies to most of our customers, while not being too restrictive that we get in the way of them deploying their own controls. And then finally, this is something that we've been preaching for a while, and then if anybody's ever seen any of our other talks from my boss or whoever, we really want to be invisibly ubiquitous. What does that mean? Well, we want to be lightweight. I don't want to deploy an account that's already spending $1,500 or $2,000 a month before I even give it to you. I don't want to drop hundreds of corporate users because of all the different services that we require into your account. I want it to look like it would if you'd open it at home with some value add. In order to do that, we really had a bias towards lightweight native tooling. Excuse me. So our tenancy model. This is what our environment more or less looks like if I really abstract this to a high level. We have our restricted accounts that we use as operators that we feel are very important, like our organization's master. We have different services that create accounts, our CMDB where we store all of our assets. But ultimately, we built an ecosystem that lines to our resources and requirements and allows us to isolate where needed, maintain centralized control over highly critical, high-risk accounts. And then, we kind of abstract layers down from there. So we have those accounts, and we have our admin accounts that really provide all of our services like billing, logging, security, and those are where a lot of our other corporate teams live. And then some of our more sophisticated business customers, because we do have such a diverse set of application teams. Some of them are new to AWS, and some of them have been operating very effectively and efficiently for years. And then finally, at the lowest level, we have app team accounts, and the important thing to remember here is not only do we have a shared responsibility model within the entire overall ecosystem, but we actually do have a co-tenancy model, if you will, within the account, where we've really tried to abstract an admin layer away from the application team layer and still not really get in their way. So how do we do this? We pretty well deploy, by default, all of these services in order to maintain the security and safety of an account. I'm only going to be able to get into a few of them before I hand it off to kind of the more interesting stuff, which is the incident response. But we use everything from KMS, WAF, Shield, Guard Duty, Cloud Trails deployed in absolutely every single account as the first thing that we do. We leverage all the different networking services. Pretty much everything's in there when you receive your account. So what shared services how do we build shared services on top of those tools that allow us to provide security, incident response, consistently deploy our environments? And ultimately, we build a bunch of different microservices. So anytime you provision an account, we go through an API that we'll walk through here in a minute, and basically it goes and it stamps out the exact same set of services that we talked about that apply to every single account at GE. We aggressively retrieve information about resources in all of our accounts. In addition, through a service that goes out and basically does a bunch of describes. We also have the inbound config and the event-driven notifications so that you kind of get that overlap and understand that at any given time you have a complete picture of what you've deployed in all of your accounts in all of your regions. We've got a bunch of different bots that can be driven by event-driven configurations, and we'll actually perform some analysis and some remediation. And then we've got a little bit more aggressive bots like tag bots that make sure that you know how to tag and it's in line with our minimalist standards and you have the absolute minimum we need to provide our security services. And then one of the things that we've done, I don't know if for those of you who have seen Aardvark and RepoKid, that's a Netflix tool that's open source that actually takes and repos all of your resources that are in IAM and sends them into version control. We actually like that tool, and we also use kind of the inverse. And we actually have a tool that allows you to create those IAM policies and roles and trust documents, creates that mapping, and it actually stores those in version control as the source of truth. And then we have a tool that aggressively goes and pushes those out and maintains state, if you will, so that if any changes are made in IAM to any of our admin roles, we actually go in and overwrite those by using an MD5 and a little bit different math to make sure that everything's mapped correctly. So we have a lot of different tools that we've built in order to maintain separation between the customer and the admin control plane within an account where it's not natively possible. So here's just a real quick look at, before we dive into some of this code, what the backend service looks like that builds an account. Essentially, what do we do here? So we're going to do a quick post with some minimalist information. I think the name of this account that we kind of thought up was Purple Spider Prod. And so we name the account, we provision it, we add the email and so on and so forth. And it takes a couple seconds to get the organization's response back from the Create Account API. But as you can see, within about 5 seconds, I ran a secondary GET request, and I've already started to receive timestamps on the creation of the account, a couple of other different factors. And if I go to the next slide, within about 9 minutes, I think, was the end result. We had verified CloudTrail had been injected, flow logs had been created, guard duty had not only been turned on, but had been associated with our security master. I think that one took the longest. And then one of the other things that we do is we turn on enterprise support in every single account. For those of you that are enterprise customers, that's been crucial for us because it actually allows us to escalate and get to engineering teams much, much quicker. We get resources like Sarab kind of at our beck and call. We call him Batman. But essentially, anytime I need something from him, if there's an error code that looks a little bit nebulous from the console, we can ask him directly, and he'll give us further detail. But it also comes with the full Trusted Advisor suite, which we actually use to check all of our buckets and things like that and throw that back into the CMDB. So how do we build this service? Most of our architecture is using API gateway to SQS. We have various lambdas. We store and timestamp everything Dynamo, and there's a few other services in between. But effectively, for flow logs, CloudTrail, guard duty, our base IAM roles that we inject into account, we just have a simple message that gets popped into SQS, and then the various lambdas go and they pick that up and they perform calls via the Go SDK to go and build that service out in a new account. And in the example that we had earlier, that took about 9 minutes. Just a real quick look at what one of those functions look like. It's really simple. We assume role into the account. We'll turn on the CloudTrail. after we build the service, and then we'll go ahead and start the logging, and we pass all those configurations in through the SQS message. Here's our guard duty deployment. This is actually the function that we have in prod today. Again, we receive our message, we create our detector, we invite the member to the master, we go back into the master using assume role, or sorry, into the target account to assume role. We accept that invitation, and then we go ahead and update the item so that when I go and I hit that service to do a GET request, I know exactly when that service was created in that region, so on and so forth. One of the things that I think is going to get fixed when guard duty integrates with organizations like a number of other services are looking to do is some of the sequencing of this is really tricky, so I'd pulled out some of that code, but they're going to be making that a little bit easier for us to consume pretty shortly here. So what identity services do we use and how do we use them? We use organizations and we build OUs that really align to our product strategy. We're very deliberate in the decisions and the way that we constructed this because you have the ability to dramatically impact an account if you don't have them organized correctly. So we really use the SCPs to filter out services that either a business doesn't want to use at a very high level or that we've deemed a little bit riskier than we care to use. Our IAM, we make use of the delegated admin feature, which is the policy or permission boundary, to do anything that's a little bit more specific in an account to make sure that our app teams are enabled and have the ability to access what they need, but we've protected admin resources using the native services where we can. And then again, we've abstracted away the source of truth for all of our policies into a Git repo. And the two tools that do that are actually IAM the truth and our resource assassin. So basically, we go and we generate all of our artifacts and we throw them into Git. And then we have a really dumb process that basically trolls over all those resources and describes everything in IAM and makes sure that they all match at all times. Excuse me. The organization's SCP, here's a couple snippets from it. So, since we're already creating CloudTrail, we don't do a create or delete. We've already tagged and have everything proper. We've already got the logging where we need it. Same thing with config. Direct connects, anything with reach back into our internal network. We want to make sure that we understand or we're the ones that provision that access or modify it in any way, shape, or form. Same thing with your northbound internet traffic and then any of your DNS, VPC. There's a number of other ones in there, but at a very high level, we filter these calls until you have a reason to access them. So what did we really cover here? I'm a little bit ahead of time, which is great because Strum has a lot of good stuff to go over with you guys on what we do. Once we've identified, added all of our resources into a CMDB, we now have a really quick centralized way to access all of those through an API. And so if we need to do any kind of enhance on our logging, on any of our alerting, that's already all there. And then we've gone through the basic protections that we deploy when you have a new account out of the gate that are natively available that really make Strum's job a lot easier. So without any further delay, I'm going to introduce David Strum. He's a senior staff incident responder at GE, and he's got a lot of really detailed technical content to go over with you guys today. So thank you.
Thank you, Thomas. Hello, my name is David Strum, and for the past, 17 years or so, I've been in information technology at some capacity. About 9 or 10 of those years has been devoted to information security or cybersecurity, the last 7 of which at GE, and the last 3 or 4 of those years has been immersed in our cloud journey. So, our secure cloud journey. It's a little different than running enterprise threat detection on-prem. Quickly, you have to understand that you do not know what you do not know. And that can be a real humbling experience when you're used to executing and performing at a certain level with certain capabilities, and you might not have those in a cloud environment. It really makes you think about, what am I defending exactly? And I've seen over the past few years that I've been involved in our cloud journey that and at GE, there's a maturity that happens A lot of times off the start, it might be just lift and shifting your workloads into EC2s, in the cloud. But what happens when you don't have EC2s anymore and you're running serverless and Lambdas? Like if you saw the keynote, the top item was Lambda, right, and serverless. So those are some of the challenges where you have to rethink what threat detection actually looks like for those types of environments. Also, what threat detection scenarios keep me, awake at night, right? So account compromise. How can somebody compromise any one of the accounts that are provisioned by Thomas and his team, whether it's keys into GitHub or if it's being phished, if you have identities that are maybe federated into an environment, you could have your admins, targeted. So there's some levels there that you can implement because we truly believe in security, security with many different layers, right? There's not one thing that can solve it all. They have to work together. So that leads into what can I actually see? So when Thomas spins up new accounts, we're thankful that all of the tools basically that we need and roles and everything that we need to provide threat detection, monitoring, and execute incident response is already baked in at the top. So we don't have to repeat that process every time, because when you're talking about 500 accounts, some customers have way more than that. It can be really daunting to have to do that every time. So that automation is a blessing for us. But visibility goes for platform, so like CloudTrail logs, CloudWatch config, those sorts of things that give you insights into what's going on. What's happening at the instance or the EC2 layer, because with the shared responsibility, there's that line you have to jump over from platform to what's happening on the OS and the different threats that can compromise at the OS layer. And if you're familiar with the attack framework, there's some overlap there with the OS layer. So all of our existing detections and frameworks and everything that we have for like a standard physical asset would apply to that OS layer. Also the network. And this was a big thing for us because we were fortunate to have a lot of tools that were built by a lot of very smart people that gave us the visibility into what was going on into our enterprise environments. And as Thomas mentioned, we're 180 countries around the world. We're pretty much everywhere. And that is an expansive network with a lot of ingress and egress points to keep track of. But initially, and I think it's easy to get in that lift and shift mentality like I mentioned, so we thought, hey, let's take our inspection stack and let's virtualize it and let's throw it up in the cloud so we can monitor our ingress-egress traffics out of our VPC. Well, what led us to that was we found out that we were completely blind to DNS traffic. And in testing, going through threat scenario tests on the backside to test our visibility and where our gaps were, we noticed that we could not see DNS. And so, we could essentially exfil over base64 encoded text records, for example, and we did not see it because our DNS requests were hitting the internal resolver and we didn't have that visibility or insight. So that made us have to rethink about just DNS and really our network censoring in general. So we threw bind servers in there, which basically on the behalf of an internal instance will take that DNS request and it'll either go north or south depending on what domain needs to be resolved. But that gave us the level of visibility for DNS. But unfortunately, we didn't have the coverage that we thought we did. So we had I guess a moment of reflection, right? While we thought we covered a gap and we high-fived and that was great because we did, it did lead, because of that lift and shift mentality, it did lead us into an operational nightmare, right? So we had this inspection stack on our NAT instances, not NAT gateways at the time, and we loaded it down with our inspection stack and it was causing nightmares for a lot of teams. So when that happened, we About a year ago, really, we celebrated our 1-year anniversary, I think on the 17th or 18th of November. Last year at this time, during reInvent, during a weekend, we were around a conference room table, and we were deploying guard duty across all 500 of our accounts in VPCs in quite a hurry. And so it was across all regions, 500 accounts. The automation that Thomas described earlier was really on point and on time to help us do that quickly. So within 24 hours, we were there, and within a couple of hours of actually deploying it, we were actually working our first incident based on guard duty findings. But after you've deployed it, you've enabled it, across all your accounts, then what do you do? So not everybody might live in the guard duty console. I think most enterprises, they try to achieve like a single pane of glass. And for us, we have various environments that we monitor. So getting that into a central place where our analysts can, triage was paramount for us. So we established a logging pipeline. So and how we did that, and here's a diagram, a simple diagram. So we have the master account, which I think now supports up to 1,000 members. At the time that we went live with it, and it was in the middle of beta going into GA, so that was kind of interesting too, to work out some things. But at the time, I think the limit was maybe 100 accounts. So we actually had 2 masters until they increased that 1,000 limit. But essentially, we have all of our member accounts rolled up to a single master, and those findings are going to a central CloudWatch event bus. And then from there, we're using Lambda to read from the event bus, and it's dumping all the raw JSON guard duty findings in an S3 bucket. And in that bucket, those objects, the JSON objects, might have multiple findings, like in one object. So once we hit that, we had an SNS topic that's monitoring those object rights. And then we have a Lambda function that basically parses all those findings out in the object, cleans them up, and then drops them in another S3 bucket, and it's based on region. So we don't just have, say US East 1. When Thomas spins up a new account, we automatically have all regions, all accounts going to a central location. And then from that, you have the flexibility there. If you want to keep it in AWS, that's fine, but not everybody operates the same. And honestly, I can't tell you exactly how to do all this. I can just tell you our experiences and hoping that you learn from what we've done. But it does give you some flexibility to send it off to, if you're running a SIM or a SOAR, whatever acronym of the day, is. And then once we have the pipeline, once we have alerts flowing, you have to understand really what is going on in your environment. Truthfully, I don't want to send alerts to the console that I don't want my analysts to take action on. It's just a waste of their time. And if you're filling up the console with, whatever, and it's not really actionable, to the point of running an incident, then I don't want to introduce fatigue to my analysts. So there's some things that we filtered out, and we could use CloudWatch, we could use Lambda to filter the things out, and if you send it out to some other tool for your glass or your aggregation, you can also filter it there. But tune and filter on what matters. And like I mentioned, you can do this with CloudWatch and Lambda. You can write basically signatures that look for certain things within a guard duty finding that might be particularly of interest to you. And then design specific playbooks based on the finding type. So for example, and I'm sure whoever's got guard duty turned on, if you've got assets on the edge on the internet, you're going to get spammed with like port probes and SSH and RDP brute force and things like that. It happens all the time, right? But honestly, I really don't care about that unless it leads to a session. And then I need the other data points there to really frame that picture of what's going on. Because you might not be able to see the whole picture just with flow or other things. You need to cross that boundary into OS level to see if there was an RDP session started as a result of that RDP brute force. If not, you can do protective things. So if you're getting spammed or brute forced or whatever, write a Lambda function that's based off of that finding type, and then might update a NACL for maybe 24 hours. So then it doesn't matter, if they're hitting you, it's not gonna, they're being blocked essentially for a temporary period of time. That's just an idea. Another example would be if there's a beacon, right? That's a whole different scenario, because now you've got outbound traffic potentially to a C2 server, for example. You can write another playbook with Lambda and CloudWatch that does other things. So, it could run your live response collection, for example. You could run contain, and we'll get into some of that a little bit later. And the last thing I have is GuardDuty. They've got threat lists that they use that they're partnered with. But GE, we're really fortunate to have a cyber intelligence team that is all the time, vetting indicators and things like that, and dropping those indicators in a database that we have internally. And some of these indicators we can't share just because of legal reasons. But we've fully integrated the IOCs, and for right now it's IPs, because right now GuardDuty ingests IPs on their threat watch list. I think you can have up to 5. But we've operationalized our IP-based indicators from our fully vetted database. Basically writes an S3, a text file in S3 that GuardDuty can ingest and can alert on IPs that we are tracking as, most of the time targeted. Some of the other detection points would be CloudTrail. CloudTrail is it's a wealth of information of what's going on in your environments on the platform level based on your API calls that are happening. It can get really loud, really chatty, and it can get really expensive if you're shipping that off to some aggregator or something. So, excuse me. So what we do is we have, and Thomas went over this, the centralized logging of CloudTrail across all regions, right? Because we want to see everything. I want to see everything I possibly can. I might not be able to do something with that piece of data at the moment, but I still want it, right? But exporting that to the eyes on glass, like I said, for 24/7 monitoring. But you can also just keep that in natively to AWS, like again using CloudWatch, CloudTrail, Lambda, and then you can take actions on that, like the playbooks that I just described. And one thing that I've really noticed about shipping CloudTrail or VPC Flow or anything for that matter is latency. You really don't want to introduce latency if you're a real-time threat detection shop. I don't think it would fly if you had a root login from some other odd IP address that you don't know, and you don't get that alert for like a day, right? Or maybe even an hour. Like you want to know when someone's using a root login on one of your accounts pretty quickly. And alert enrichment as well. So the DNS issue. So with the bind servers, we used Kinesis agents on the binds, which is streaming data over, and then we can feed that into Firehose, which, so bind log, if you guys have seen bind logs, but the regex for it to carve out what you want and to get it, in the right format can be a little tricky. But we've got a Lambda function that does that within Firehose, and then it writes to S3, and then we created a glue database and tables that will we can, for the sake of querying performance and cost, they're in Parquet format in Athena. So we can also, through like API Gateway, we can trigger queries from outside of AWS, like from our SIM or aggregator or wherever the glass is, and we can enrich these DNS findings because of our particular setup with bind servers. We had, for every DNS alert, it was the bind server IP. So we've had analysts ticket bind servers, and then they notice, well, this is the same IP, So, what's going on here? Well, we use this bind logs to enrich the original alert so that we can find the true IP address. But with new services that Amazon comes out with, their enterprise services team is really great, and we've been partnering with them and working with them for guard duty to make guard duty better for us, but also make guard duty better for everybody here in this room and all the customers that use it. So a little bit of our incident response. Containment. Containment's a little tricky. It's not really so much who or what it is, but who is doing the containment. So if your containment gets out of hand, you can really shoot the business in the head if you're not careful. But containment to us really just means preventing access to an EC2 or a user. So cutting network traffic by throwing it in a security group that's isolated. Any API communication to that instance so that nobody can manipulate, the attacker can't manipulate that EC2 like during the incident. Any changes, any authentication to services if that EC2 has an instance profile or a role associated to it, that it can't do anything from that. We want to completely isolate this EC2 instance. And then we spin up, and I have a diagram that basically shows the whole process. But the only thing that we want really to talk to that infected instance is our analysis server, which we deploy out into the VPC of the infected, and then we can execute remote commands from that analysis server to the infected, collect all of our stuff, and then get out of Dodge. So basically, it's like firefighting, right? Like they roll up on the scene, they take care of business, and then they roll out. And that's how I like to see it. This is also for users. So if you have a role or a user, or ARN for that matter, that's going sideways or is compromised, then you can cut the keys, you can reset keys, you can cut any like shell access that thing has at the moment. On the other side is, since we don't have the luxury sometimes of like deep packet inspection and the things that we were used to on the enterprise side, that's really driven up the need to do more host-based forensics. So the live response collection at the beginning was a little clunky before we started adding automation to it and using native services like SSM. Because when you're running an incident and you're trying to collect information on a box and you're waiting on the phone for like an hour or two before you find the system owner or the application owner that has access to that instance to run scripts on your behalf, that feels like forever, right? And anything really can happen in those 2 hours, much less not meeting SLAs, right? So using SSM to do all of our manual tasks on our behalf is really a lifesaver. Granted, that sort of adds like a backdoor to all your systems, but if you layer on top of that security monitoring over those identities that are allowed to do that, then you can really monitor when that is being misused and then take action. So one thing that we've learned is our package that really does the collection, it's you don't want to run it on the system volume. So that's why we deploy and automate the attachment of volumes and then launch the package from that volume, save everything from that volume, and then we can take that volume and copy it and attach it to whatever we want to, or our analysis server. And then once we have all that collected, we have our forensic EC2. This is loaded up with analysis tools and frameworks and process all that, and then we can give it to our analysts for them to analyze, scope, and then rinse and repeat as necessary. So real quick, here's just a quick diagram of that in action. So it could be a Python script that does, handles Boto3 libraries and uses Boto3 commands, or you can Lambda-ize it. And with the advances in Lambda, with like roll your own, bring your own libraries and everything, there's a lot more flexibility there. So you can see the two security groups, the infected, and then the everything is over SSH between the infected host and the analysis server. Now, the interesting thing with collection, because we like to collect memory and use tools like volatility, because memory can yield you things that maybe disk forensics can't. We've worked some incidents where the open source intel on this was very scarce, and it involved like some Monero miners using some vulnerabilities. But to understand exactly what vulnerability was being exploited, we had to use memory to find it. Because I think everybody can agree if you're working the same incident over and over again and you're repeating every time, well, then you're not moving the ball forward. You really only want to work the incident of that likeness one time, and then you can automate and learn from it. But with Linux, we use Lime, right? And if we basically we build a repo of memory profiles, right? And if we don't have a memory profile for a certain EC2 or our Linux flavor or kernel version, then we spin up an EC2 that's like the infected, and we build the profile on that, and then we tear that down, and then we can collect and we can move forward with our memory analysis. Windows is a little bit more straightforward. Volatility has a lot of profiles all ready to go for Windows. So, diagram on really the process, and this is really dependent on environment variables. How is your environment set up? It's probably not exactly like ours. Might not be as complex, but when you're doing cross-account, cross-region, there's some other factors involved. But this slide really just shows the steps of containment and some of the permissions that are needed in different steps of it. And we broke it down for users and EC2s, like I mentioned earlier. So we went through identify, protect, detect, and respond. And there's really a lot. AWS gives you a lot of the blocks and the tools to do this, with relative ease. With guard duty, when we rolled it out last year, we had their service team come and help us, and they were there. They were great to lean on, to bounce ideas off of, and continuously making the product better. But really, what's next? So from this point on, really from years ago when people started in the cloud, there's been maturity, right? There's been different services. There's things that make application teams, more agile. Now you have DevOps and CI/CD pipelines and things like that. There's just different behaviors that application teams, have when they're building the tools and apps that makes the business go. So I see in the future really true ecosystem monitoring, right? And what does that mean? I mean, it's complex, it's all interconnected, and it's less bolted on and more, part of the ecosystem, right? I think it's like the human body, right? When there's a germ or something like that gets into the body reacts to it, and there may be some pain and stuff, but it's built into the body. It's like an immune system, right? And that's how I see it moving forward, using everything as a sensor. So we have like VPC flow centrally, OS logs centrally, all this telemetry, your change management system, the data that's in there that you can use with your vulnerability management system, with your threat intel system, all these systems together that you can actually paint a clear picture of what is going on. Because if I can keep my analysts from having to do a real in-depth and intensive live response collection, and I can give them the data that they need up front, and enriched, and I can do that with the native services that Amazon provides, that we're happy campers. But even further, we have containers on the rise, right? So what does threat detection in containers look like? What does monitoring and response look like for containers? Kubernetes, Docker, all that stuff. And then CI/CD pipeline. How many people have found a Jenkins server on the internet that's just got admin just sitting out there getting blasted, right? Exactly. So that can introduce a whole attack chain. And what happens when you have your CI/CD pipeline poisoned, right, with malicious code? Can we detect that? And with the improvements that Amazon has made to their services, these are things that we're going to need to understand how to do and really wrap our minds around a whole different way of thinking when it comes to threat detection and incident response. And really, I see IR, or incident response, as code, just like you have infrastructure as code or X as code. So with that, I just want to say thank you. I'll invite my colleagues back on the stage. We have some time to do a little bit of Q&A, and then after we have about 30 minutes for a meet and greet. If there's some topics that you heard that pique your interest and you want to dive in a little deeper, we're more than happy to do so. And also, please complete your survey in the mobile app.
All right. Thank you. Thank you, David. Thank you, Thomas. We can take a couple of questions from the audience if you have any. Otherwise, we can meet at the ARIA lounge as well in 15 minutes.
Yeah, there really isn't. And really what we do with SSM, it's a combination of using SSM with Lambda step functions. So we can check for like an instance profile on the box. If it doesn't have one, we can add our instance profile, which gives us the run command access to do that. So yes. Yeah. How do you pipeline your stuff for account provisioning?
So we effectively, we get a request from an application team or whoever, and we have a very standard build that, with a couple different minor tweaks in configuration, once that hits that API, everything gets into SQS. So it's fault tolerant, we do multiple retries, we have a DLQ, a ton of notification, and then everything gets stored in Dynamo, so that we have full CRUD API on top of that. So everybody that has it, you can plug in a number of different chat tools. I don't want to name any here, but we can interact it with different interfaces, GUI, whatever it is that we want to. I just showed the back end so that we didn't have any other tech on top of it.
And for other sources like VPC Flow and things like that, and host level stuff, most of the time it's Kinesis, right?
Yeah.
And then that'll allow you to use Kinesis Analytics to do some of your hot pass stuff, and then you can go on to S3. Really, the sky's the limit. We're using EMR, to transform the data, and doing correlations across many different data points. But for the most part, it's centralized with Kinesis.
Yep.
You guys obviously have a bunch of compliance stuff that you run across lots of industries and everything. Have you found any way in any of the AWS services to store baselines based on certain compliance requirements? Whether it's FISMA or FedRAMP or standards to actually store baseline configurations?
Yeah, sure. That's a tough problem to solve. I think we've done that a couple different ways. We've gone through and we've done our documentation. Probably in the past, it's been done manually on pen and paper. I've printed out the FedRAMP doc itself. It's like 600 pages, right? But we've also used GitHub, and we've gone through all the controls for a couple different frameworks. And I think now what we're really looking at doing is kind of actually taking that doc, making a living thing, maybe putting it into a wiki or whatnot, and then actually having all those references to the architecture and all of our responses in there. But yeah, it's still a pretty manual, laborious process, and you've got to have that all in one place for an auditor, to get, yeah.
And it also makes life easy for us because we've got detections that might not be in guard duty. They're specific to our pool of accounts. So for example, I don't only want to know when EBS or RDS snapshots have been made public, but I want to know when they've been shared to a non-GE account. So having that authoritative lookup that's accurate and running, greatly helps us as far as like what accounts we are actually protecting and what is a foreign. The same thing with like principals. So we'll look at policy documents, trust documents for any principal that is not a GE principal. And it happens, but that's why I mentioned change management, because if you're doing a POC with a vendor, right, and they want you to add a trust policy to their account to do the thing, well, that's something that can be set ahead of time, so that can basically tune on the fly. It's like dynamic threat tuning. So
we also deliver with like a full PDF release doc, so that we have our engineering responses, we have the basic controls that we believe we've satisfied or that we'd be able to attest to, kind of like Amazon has their SOC 2, right? Then we'll deliver you the PDF, and then ultimately right now the business is responsible for for HIPAA or whatever it is that they're pursuing. But yeah, that's kind of how we handle that.
Yes, sir.
Yeah, in your automated account provisioning process, like what kind of tools are you using there? Are you just doing all your own scripting? Are you using cloud formation?
Yeah, so it's all Lambda functions that using the Go SDK call all the APIs directly. We ran into issues like with guard duty, for example, that some of the other abstraction layers didn't support all the API calls and all the specifics in the configuration that we needed. So I just decided, hey, let's just go direct to the SDK and put them into Lambdas, and we've had that all pipelined. We use a number of different frameworks to manage that. But yeah, those are all basically Lambdas that use SQS and API Gateway to send that out, and then Dynamo to hold it.
Can you talk a little bit about your centralized logging approach? Amazon has a couple of different blogs and white papers and stuff, kind of pushing you in one or two directions.
For CloudTrail?
Sorry?
For CloudTrail?
for anything.
For anything?
Security logging, whether it's CloudTrail or config or anything, you want to get into a centralized place.
Yeah, so when we were looking at that, and we're looking to see like what Amazon has in documents and what other companies have, a lot of times you see like single account, single region, sort of scenario, which doesn't apply to us since we have a centralized like incident response, zone or account. But for the most part, it's kinesis into S3. But then it's like, what do you do with that data, right? So, transforming it and using tools like Glue to make your Glue catalog so that you can build database and tables and you can correlate that stuff together. That's really the direction that we sort of see it versus doing all this stuff in like a third party.
And being that we're a larger enterprise, we'll actually separate the CloudTrail config, maybe host logs in different accounts.
Yeah.
So
Yep.
we decided to create a new account based on identity and networking boundaries. And generally because of service limits and some other things that we do run up against quite frequently, we'll just basically say, CloudTrail goes here. We're going to have this as our centralized config. We're going to have host logs go here, and we'll just create new accounts. And that makes it a little bit easier, too, for the team that's supporting that application to then go ahead and provision identity as they see fit along lines of their team.
And it's a mix.
Both, yeah.
Yeah, it's a mix. Yeah, I'm trying to go more cloud native because we don't just live in one environment. Unfortunately, we're pretty much everywhere. So having that enterprise on-prem monitoring thing, AWS, X, and YZ, to where we can, have that global picture is crucial for us.
Yes,
Yep.
You guys talk about all these scripting, is any of that open source?
We could probably share some of it. It's honestly something that I meant to do, and I just really haven't gotten around to it.
Yeah, and I failed to mention earlier, but we could talk about this stuff for hours, right? So, if the interest is there, we can dive into this a lot more and maybe have a full-on like end-to-end demo if people are interested, like in a further talk down the road. So just keep your eyes open for that.
And this is just the start. So we are going to continue this session at various AWS events as we get better. You might have heard about newer security services that we didn't talk about today. So GE is going to adopt those, and then in future events, probably discuss how that integrated into these mechanisms.
I think one of the main challenges is you've got 1,300 new services and tweaks and enhancements a year, right? So you got to just drop anchor, commit, and decide, right? But if you start with what do you actually want your thing to do, really from a requirement standpoint, and don't focus on, what AWS service can get me this, what AWS service can get me that. If you just come up with exactly what you want to do and like work with enterprise architects and other people in your organization, it'll flush out, right?
I think we're going to get cut off here, but we can come grab you and maybe meet you downstairs. Yeah, awesome.
Yep.
Thank you.
Thank you.
In 15 minutes, we're going to be at Aria Willow Lounge 1. So we all three will be there. You can carry on discussion there.